This video is for integrated 3. This is the chapter 5, D-Day number 4. On this, the very first problem, I do want us to accurately graph this. I know it's a sketch, but I do want us to accurately graph the logarithm and its inverse, which is an exponential. Then we're going to also draw in the asymptotes, give the equations of the asymptote for both of them. So for this one here, if I'm trying to find my locator point, okay, my locator point is going to be what makes that 0, which is -4, comma, this -2. That's going to be my locator point. So I am going to go to -4, -2, and I am going to put a point at, let's get my mouse over here, -4, -2. And my asymptote is going to go through that. My asymptote is going to be what makes that logarithm. Okay, when I'm taking the log, I'm taking the log of 0. Log of 0 is undefined. So what makes that 0 is when x is equal to -4. So that's where I'm going to have a vertical asymptote. Okay, so let me draw in my vertical asymptote right through here. And I'm going to label the equation, and this is x equal -4. Now from here, I am going to just be thinking about log base 3 of 1. I always do 1. Log base 3 of 3. Log base 3 of 9. I'm doing nice 3 to powers. My next one would be log base 3 of 27, but that's not going to fit on my graph. Okay. Log base 3 of 1 is 0. Log base 3 of 3 is 1. Log base 3 of 9 is 2. And log base 3 of 27 is 3. So that's what I'm going to be thinking about when I'm graphing. So I'm going to come over here to my locator point. This is where I'm going to start. This is the level I'm going to be going out at this height of -2. So I come out 1. Okay, log base 3 of 1 is 0. I come out 1, 2, 3. Log base 3 of 3 is 1. I go out 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Log base 3 of 9 is 2. And then I'm going to connect this. And it's going to be kind of looking like a square root graph-ish, but it doesn't stop here. It continues. It gets closer and closer to that asymptote. And that's my log graph. Now, to find the inverse, I am going to take this equation and switch my x and y. So, and then I'm going to rewrite it in y equal. So I'm going to go x is equal to log base 3 of y plus 4 minus 2. Now, in this situation, I am going to try to get my log by itself. That's going to be my first step. So I am going to add 2. Now, when I do that, I end up with my logarithm with my y inside, and I'm trying to get that y undone. So to undo a logarithm, I'm going to rewrite it in exponential form. So I'm going to have 3 to the power of x plus 2, because that's what logs equal. Logs are equal to the power. So that's what my log equals. So that becomes my power. Okay, so now log base 3, 3 to the power x plus 2 is equal to y plus 4. My very last step, I'm going to subtract the 4. And that is our equation. That is our exponential equation. Our locator points can be -2 because that's what makes my exponent here 0. And -4 because that drops my graph down 4. So -2 comma -4. Okay. So let me go to -2, -4. So -2, -4. Let me just get my cursor over here. So -2, -4, going to go right there. And I am going to have an asymptote going through this. Now, these ones have an asymptote that is going to be horizontal. So it is going to go horizontally through that point. So this equation of this horizontal line is going to be y equal -4. So you'll notice that my logarithm was x equal -4. Its inverse, which is my exponential, is y equal -4. Remember, inverses x and y get switched. Okay, so now I'm going to graph this. I'm going to start here at this starting point. Okay. And from here, I'm going to go 3 to the 0, which is 1. Go over 1, 3 to the first, which is 3. I'm going to go over 1, 2, 3 squared, which is 9. So that's going to be 4, 5, 6, 7, 8, 9. And that's all I'm going to be able to fit on here. And I'm going to connect it. And it's going to get closer and closer to that asymptote. And there's my exponential graph. Now on 2A and B, we're going to be graphing logs again. Okay, we're going to be talking about domain and identifying the asymptotes. Okay, so in number 2A, I am looking at log base 3. So again, I'm always thinking log base 3 of 1, log base 3 of 3, log base 3 of 9, which is A0, A1, A2. Okay, so my locator point is going to be 1, 1. So I'm going to go to 1, 1, which is right there. I am going to have a vertical asymptote through this. So I'm going to draw my vertical asymptote here. Okay. And I'm going to label it. I'm going to label it here, but I'm also going to label it up where they're asking us. So this is going to be x equal 1 because it's what makes this 0, and I cannot take log of 0. So x equal 1. Then I'm going to come to this starting point, this locator point, and I'm going to be thinking about this. I go out 1, log base 3 of 1, 0. I go out 1, 2, 3, log base 3 of 3, 1. That's all the nice ones I'm going to be able to fit on. And then it comes like this, almost again, looks kind of like a square root graph, but it doesn't stop. It gets closer and closer to the asymptote. My domain for this is going to be, let me just kind of draw a vertical line for a second. Okay. So my domain is how far to the left and to the right, and if there's any gaps in between. And there aren't any gaps in between, but the furthest to the left this graph goes is 1, but it doesn't reach 1. It gets closer to 1. And then it goes out forever and ever to infinity. Okay, so my domain is going to be from 1 to infinity, or you can also write it as x is greater than 1. For B, this is going to be log base 4. So I'm thinking log base 4 of 1, log base 4 of 4, log base 4 of 16. So this is going to be a 0, this is going to be a 1, this is going to be a 2. Now, my locator point for this is going to be -3, 0. So I'm going to go to -3, 0. -3, 0. Okay, I am going to have a vertical asymptote going through this. Okay, so let me draw my vertical asymptote through this. And the equation of this is going to be x equal -3. That's going to be my asymptote. Then I am going to be graphing these log base 4. So if I go out 1, log base 4 of 1, 0. If I go out 1, 2, 3, 4, log base 4 of 4 is 1. I'd have to go out to 16. That's not going to fit on my graph. So, oh, sorry. This one, I apologize. This one is a negative logarithm. Okay, so with that negative, what's going to happen is it's going to be the same idea, but I'm going to be timesing it by a negative each time. So as I'm going out 1, log base 4 of 1 is 0. 0 times a negative is still 0. As I go out 1, 2, 3, 4, log base 4 of 4 was 1, but I'm going to times it by a negative, so I'm going to have a negative 1. And if I had gone 16 out, I would have gone down to a negative 2. Okay, now let's draw this. So this one looks like a negative square root. Okay, but it doesn't stop there. It comes and it gets closer and closer to that asymptote. Now for this one, if I'm looking at this, the furthest to the left it goes is negative 3, but it doesn't touch. And the furthest to the right it goes is infinity. So I'm going to write negative 3 to infinity, both open brackets, or x is greater than negative 3. Okay. Now solving these. So when we're solving a log, we're going to rewrite it in exponential form. Remember, a log always equals the exponent. So that's going to be my exponent. So this is going to be 3 to the negative 4th is equal to x. Now remember, 3 to the 4th is 81. When you have a negative, it is the reciprocal. So this is going to be a 1 over 81. That's going to be my answer. On B, again, your log equals your exponent. That's going to be your exponent. So when I rewrite this, this is going to be 8 to the x is equal to 1 over 512. Now, I'm going to focus on 512. I'm going to see if 8 is to a power gets us 512. I've got 8 times 8 by 8, I get 64. This would be without a calculator. So if I was going to take 64 times 8, that's 32. I get 48 plus 3, I get 512. So 8 to the 3rd is 1 over, I'm sorry, is 512. But I want 1 over 512. So that means my x is not going to be 3. It's going to be a negative 3 because that will flip it and make it a reciprocal. On C, again, your log always equals your power. So that's going to be my power. So I'm going to have x to the negative 1/4 is equal to 2. And what I'm going to do is I am going to raise this to the reciprocal. So I'm going to raise it to a negative 4. And I'm going to raise the other side to a negative 4. Now, when I do that, power to power, I multiply. So I am going to be left with x to the 1st, or just x, equals 2 to the negative 4. And when I take 2 to the negative 4, remember, 2 to the 4th is 16. So 2 to the negative 4th is the reciprocal of that. So I get 1 over 16 as my answer. Okay, on number 4. Okay, we're going to find the inverse. Now, first off, what I want us to pay attention to is what type of graph we're starting with. That's kind of nice to understand. So this is a parabola. Okay, it's a parabola. I could really rewrite it like this if I wanted to. So that's really kind of like our A. Maybe you'll see it more as a parabola when it's in that type of a form. Our vertex would have been at negative 8, I don't know why I'm writing negative infinity, negative 8 comma negative 12. Now, I should be getting a sideways parabola back as my inverse. Okay, so just kind of keep that in mind. Okay, so the first thing I'm going to do is I'm going to switch my x and y. So I'm going to have x is equal to 3 times y plus 8 squared over 10 minus 12. First thing I'm going to do, get rid of that minus 12. So I'm going to add 12 to both sides. 3 times y plus 8, let me get my plus better, plus 8 squared over 10. So I'm going to get rid of two things. I need to get rid of this 10. I was going to try to do it in a different color. Sorry. I'm going to get rid of this 10, which since it's dividing, I would multiply by that. I also need to get rid of this 3. Since it's timesing, I'm going to divide by that. So I'm going to kind of do both of them in one step. So I'm going to times by 10. I'm going to divide by 3. My next step, I'm going to square root, okay, to get rid of the square. Now, when I square root, okay, I always get a positive and a negative. That's how I'm going to get the positive branch and the negative branch of this sideways parabola. Otherwise, I'd only be getting the top part. So plus or minus the square root of, and this whole fraction, sorry, I was trying to get rid of this, the whole fraction needs to be underneath it. The 10 times the x plus 12 all over 3 is going to be underneath that. And that's going to equal, I'm going to write it in blue so it kind of contrasts with this. Let's see here. Let's see if I can move this, see if it'll cooperate with me. That's going to take everything. Maybe I can do it this way. Okay. Just move this over here. Don't need that. Okay, so that's going to equal y plus 8. And then I'm going to subtract the 8. I'm going to put the negative 8 in front just so I don't lose it underneath my square root. And again, that whole fraction, not just the top, has to be literally underneath that square root. And that's our answer. If you don't give me that plus and minus, you would only be getting part of the parabola, the upper part of the sideways parabola. You would not be giving me the bottom part. Okay. On number 5. Okay, so we're going to be doing normal distributions. Okay. So in this particular one, okay, we're going to be talking about November. And we're going to be doing a normal distribution. I'm just going to grab one that I already have saved here. So, okay. So for this one, our mean is 51. Okay, so our mean is 51. Let me get a little smaller. Our mean is 51. Just gonna try to snap out of that. So our mean is 51 and our standard deviation is 2. Okay, so I would be at 53. I would be at 55. I would be at 57. Going the other direction, -1 as a z-score. I'm taking 2 off, so I'm going to be at 49. I'm going to take 2 off. I'm going to be at 47. And take 2 off, I'm going to be at 45. So that's -2, -3. Okay. Now they want it to be between 45. How many days, if this is a normally distributed data, would you expect the high temperature to be between 45 and 57? So between 45 and 57. So 45 to 57. So basically it's going from -3 as a z-score to +3 as a z-score. So if you're thinking about the empirical rule, this should be about 99.7, but we're going to put it in the calculator just to in case you didn't know that. So this is going to be normal CDF. My lower bound is 45. My upper bound is 57. My standard deviation, my mu, is 51, and my standard deviation, my sigma, is 2. So I'm going to be putting this into my calculator. And when I put this into my calculator, let's see, 45, 57, 51, 2. Do it one more time. I end up with 0.9973, or 99.73%. Now, I want how many days? So I'm going to take 30 days times 0.9973. So I'm going to times that by 30 on my calculator, and I get 29.92 days. Okay, so about almost all 30 of them really are going to fall within that. Okay, so on the next one, the average score on an SAT is 1060. Okay, oops, let me just get this here. And so we have 1060, standard deviation of 195. And we want to see how many students scored at least 1352, 1352. Okay, so I'm just going to just jot this out for us. I'm going to be adding our mean, which is, our standard deviation, which is 195. So right here, I'm going to be getting 1255. Okay, that would be one standard deviation. If I add it again, I'm at 1450. That's 2 standard deviations. And if I add it again, 195, I'm at 1645. So we want to know scored at least 1352. So at least 1352 somewhere here. Okay, that's what we want. At least that much. So we really are looking at from there on. That's what we're looking for. So I'm going to be doing a normal CDF. My lower bound is going to be 1352. So that was a 1352. My my upper bound is infinity, and the way we're going to write infinity is 10 to the 99. My lower bound, again, 1352, upper bound 1099. My mean is 1060, and my standard deviation is 195. And I'm going to put that into my calculator. So 1352, 10 raised to the 99, 1060, and 195. And I ended up with 0.067139. So let's say 14. So that's going to be about, in terms of percent, 6.714%. On C, so for this one. If we're doing this one, let me just get a basic one here. So we're dealing with percentiles, so let me just have a general one. Okay. So in this case, we have a phone. Average standby time is 42.4 hours, standard deviation of 1.7. So this is our mean. We want to be in the 80th percentile. We want what value is going to be in the 80th percentile. So basically, I need 80% to be less than us. Okay, 80%. So this is going to be 0.80. Okay, and I want to find the score. So in this case, I am going to be doing the inverse norm. And when I do inverse norm, it's going to ask me for area. I put my percent as a decimal, 0.8, my mean 42.4, my standard deviation 1.7. I should be getting a score, okay, or an amount of hours that's more than 42.4 because that's my mean. So I'm going to put in my calculator, inverse norm, 0.8, 42.4, 1.7. And I ended up getting 43.89 hours as my answer. And that is more than 42.4. On number 6, we're solving a system algebraically. So we are going to use elimination. We are either going to try to eliminate our x's, which means we'll probably be trying to get a 6 and a -6, or our y's, and I would say we'd be trying to get either a 12 or an n and -12. I think I'm going to deal with my x's because that's just going to be smaller numbers. So my goal is to eliminate my x's. I'm going to multiply this equation by 3 and this equation by 2. So when I multiply the top by 3, I'm going to get 6x minus 9y is equal to 9. When I multiply the bottom by 2, I get a negative, let me rewrite that, a negative 6x plus 8y is equal to a negative 10. I'm going to add these two equations together. Notice that my x's are going to eliminate. Okay, so I end up with a negative y is equal to a negative 1. So y is equal to 1. I'm going to take that and plug it into either equation. So let's say I go 2x minus 3 times 1 equals 3. I'm using the top equation. So 2x minus 3 equals 3. I'm going to add 3 to both sides. So 2x is equal to 6. So x is equal to 3. So my answer is 3, 1. That's my point of intersection. On number 7, we're going to do composition of functions. We always start from the inside out. So first I'm going to do g of -5. So I'm going to be using this equation. So I am going to find g of -5, which means I'm going to go 3 times -5 to the third minus 4. So if I'm doing it by hand, it's going to be 3 times a negative 125 minus 4. So that's going to be 3 times a negative 125 is going to be negative 375 minus 4, which is going to be, whoops, looks like a Z, sorry, which is going to be a negative 379. Okay, but this should be on the calculator portion, so you can put that into your calculator. So now I'm going to take that and I'm going to put that into the other function. I'm going to put that into, whoops, trying to get a highlighter. I'm going to put that into F. Okay, so I'm going to put this into F. So now I'm going to be finding F of a negative 379 which is going to be negative 379 plus 4, which is going to give me a negative 375. And that's my answer. Now, in the next one, I'm going to be getting an equation. So again, I am going to be starting with g of x, okay? And g of x is equal to, 3x cubed minus 4. And now I'm going to take that and put that into f, okay? So now I'm going to find f of 3x cubed minus 4. So f up here, I take my input and I add 4. So I'm going to take 3x cubed minus 4, which is my input, and then I'm going to add the 4. So those 4s are going to cancel out, and I'm going to end up getting 3x cubed as my answer. On 8. Okay, so for this, we're going to find the mean, median, mode, range, and standard deviation. Now, for this, we can put this into our calculator. And when you put it in your calculator, you would be going under Stat, okay, Edit, and then you would put all of this data into your calculator, okay? Once you get that data into your calculator, you're going to do Stat, okay, and you're going to arrow over from the top. Instead of Edit, you want Calculate. And under Calculate, you're going to want the first choice, which is one variable statistics. And when you press that, it's going to give you most of this information. Your mean is your X bar. And so when I do this, my mean is a 7.25. My median, it's going to give me, okay, my median, if I arrow down, it's going to be under my Q1, and it's going to be 6. It's not going to give me the mode. The mode is going to be the number or numbers that occur the most. So if I'm looking at this, I see that I got a 6, 1, 2, 3 times. I don't think I have, yeah, that's the only thing that's even duplicated. So my mode is going to equal 6. My range is going to be my biggest minus smallest number. So my range, my biggest number is 14. My smallest number is 4. So 14 minus 4 is 10. 10 is my range. And then my standard deviation. And the standard deviation that we're using is going to be our population standard deviation, which is our sigma. And that is going to be 3.03. Now on number 9, okay. So on this problem, okay, I noticed that both of these have a square root of x plus 1. So I'm going to let u equal the square root of 3x plus 1. And then I'm going to rewrite these. So I'm going to write 8u cubed equals 16 raised to the 3u. I'm going to get both of these to be the same base, which is going to be a 2. So my 8 is a 2 cubed, and that is raised to the u cubed. My 16 is a 2 to the 4th, and that is being raised to the 3u. Now, when I have power to powers, they're going to multiply. So on the left side, it's going to be 2, and my 3 and my u cubed are going to multiply, and I'm going to get a 3u cubed equals 2, and over here I'm going to have power to power. Those are going to multiply. I get a 12u. When my bases are the same, I can set my exponents equal. 3u cubed is equal to 12u. I'm going to get everything on one side, 0 on the other side. So 3u cubed minus 12u equals 0. I'm going to divide everything by 3 because it's an equation I'm allowed to divide. And then I'm going to factor. I can factor out a u from each of them. Don't divide out a u, otherwise you lose a solution. Then I can factor this again, difference of 2 squares. My u squared minus 4 is a u plus 2, u minus 2. So for my u, I'm going to get 0 from here. Oops, not from here. Sorry, wrong. That's going to be my 0. I'm going to get from here a -2. Okay, so that was my -2. I'm going to get from here a +2. So that's going to be u equals +2. Now, I'm not done because I want to solve for x. So remember, each of these, my u is really the square root of 3x plus 1. So I'm going to rewrite these. This one, I'm going to go square root of 3x plus 1 equals 0. Okay, that's allowed to be solved. I'm going to square both sides, so I get 3x plus 1 equals 0. I'm going to get x is equal to a -1/3. That's going to be one answer. Then I'm going to take this one, and I'm going to take the square root of 3x plus 1, which is a principal root, and set equal to -2. That is not going to be possible because a principal root should be equal to a positive. So that one I'm not going to work out. Then this one here, I'm going to take the square root of 3x plus 1, set it equal to 2. I'm going to square both sides because it can equal a +2. That's fine. So 3x plus 1 is equal to 4. I'm going to minus 1. I'm going to divide by 3, and I get x equals 1. So I get a -1/3 and 1 as my answers. So oops, it's going to do this one in purple. A 1 and a -1/3. Those are my two answers. Finding x-intercepts. Okay, last problem. So to find x-intercepts, remember, on the x-axis, your y is 0. So I'm going to go 0 is equal to 12x cubed minus, sorry, bottom of my screen here, 12x cubed minus 2x squared minus 4x. I'm going to divide everything by, well, 2 is the only thing I can do. So it's going to make it a little smaller, at least 6x cubed minus x squared minus 2x. I'm going to factor an x out of everything and get 6x squared minus x minus 2. Now, I'm going to take this and I'm going to factor that. So I am going to do a box to diamond. So I have a 6x squared minus 2, which is a -12x squared. It's going to add to a -x. So that's going to be a -4x and a 3x. So -4x and 3x. Now, when I'm trying to find the outside of this, my 6x squared could be a 6 and a 1 or a 2 and a 3. But with the 4 and 3, it definitely is going to have to be a 2 and a 3. 2x times -2 gets me a -4x. 3x times 1 gets me a 3x. So at this point, I'm going to have my x from before. I am going to have a 2x plus 1. I'm going to have a 3x minus 2. I'm going to set each of those to 0. So I'm going to get x equal 1, x equal a -1/2, and x equal 2/3. And those are our x-intercepts. And hopefully this helps you guys out. End of the video.